Hello friends, welcome back. Today again we'll be solving a question related to signaling system. The question is as follows. The frequency response of a system is He power j omega equals 4 minus 2e power minus 2j omega if the input is x of n equals 4 del of n plus 2 into del of n minus 2. So these two are impulse functions. The output of the system is y of n. Then find y for n. So what we have to do is first we need to uh, find the value. First we need to find y of n, then only we can get y of 4n. Okay, so how to proceed with these kinds of questions? So what you can do is we can really use the properties of that we have studied with respect to the uh, Fourier transform. So the property of Fourier transform is that uh, the convolution is convolution in time domain is multiplication in frequency domain. Okay, multiplication in frequency domain. So that is one property that will be used. And how it will be used, let us first just draw what he's trying to say. So this is He power j omega, that is a system, and here he has given some input x of n and we are expecting some output y of n, and he wants us to know he wants us to find y of 4n. So this is what we need to find. Okay, so what we can do first here is we know that y of n will be x of n convolution of, okay, uh, x of n convolution of the response. Okay, so it will be convolution of what? H of n. Okay, because h of n and h e power j omega will be a Fourier pair. So this is what will happen in time domain. Okay, so now what will happen in frequency domain? Y e power j omega will be equal to x e power j omega into h e power j omega. Okay, this is what is going to happen in frequency domain. Okay, so now we know that h e power j omega is already given to us. If we are able to find x e power j omega, then we know what is it in frequency domain, y e power j omega. Okay, so you can see that x of n is given to us, which is 4 del of n plus 2 del of n minus 2. Okay, so this is given. So you know that del of n will have a Fourier transform of 1. Okay, and del of n minus 2 will have a Fourier transform of e power minus j into 2 omega. Okay, because this will be the time shifting property of Fourier. Okay, Fourier transform. So time shifting property I can write like this. It is like x of n minus m. Okay, if x of n has a Fourier transform of x of e power j omega, then by time shifting property this will have x of n minus m will have a Fourier transform of e power minus j m omega x of e power j omega. Okay, but e power, this is how many units we have delayed. Okay, say we have delayed say 10 units, so it will be 10 here. So here it is delayed by 2 units, and this x e power j omega is 1, so here it is into 1, so which means the same value. So now the combined Fourier transform of this signal is x e power j omega is equal to 4, okay, into 1. Okay, so which is 4 into 1 plus 2 into e power minus j 2 omega. Okay, so now this is x e power j omega. Now how we calculate y e power j omega? Simply multiplying x of x e power j omega with h e power j omega. So these two can be multiplied. Now multiplying these two, what we get is 4 minus 2 e power minus 2 j omega into 4 plus 2 e power minus j2 omega. Okay, so you can see here that we are able to form a, b. Okay, if we consider this is a minus b and a plus b, so again we can form a square minus b square. So it is 4 squared minus 2e power 2j whole squared. Okay, so this comes out to be 4, okay, squared, which is minus, this is again 2 squared is 4 e power minus j into 4 omega. Okay, so now this is 16 minus 4 e power minus j 4 omega. Okay, this is what we get. Now you can see here that we have got y e power j omega is equal to 16 minus 4 e power minus j 4 omega. Now you can again take Laplace inverse of this. Okay, sorry, the Fourier inverse of this. So what you get Fourier inverse as, this will be y of n, this will be 16, the Fourier of 1 will be del of n minus 4. Now it is delayed by 4 units, so it will be del of n minus 4. Okay, so now how can you show this in diagram? This, so one impulse is at origin, which has a magnitude of 16, and another is at 4. So this is 1, 2, 3 at 4, and it has a magnitude of minus 4. Okay, so this is how we can interpret this. Okay, so this can be interpreted in this way. Okay, so now he's asking us y of 4n. Okay, so he's asking us what is y of 4n. So y of 4n means you remove 3 elements in between and then you write it. So you can remove, say you take this 16, after that you remove the three elements, so all the 3 elements are removed and you take the 4th element. So what you get is this thing 16, and everything here gets removed, only you get is 4. Okay, which is minus 4, and this will be at 1. So this will be is equal to 16 comma minus 4. Okay, so for here you see B is the correct answer, so because it matches the option. Okay, so this is how we need to proceed for the problems like this. Just start with taking the Fourier transform, and then you can simply multiply it with the frequency response of the system, and then you can take the Fourier transform in inverse of the Fourier transform, and you can get the desired result. So thank you for watching this video.